Welcome to Cool Guy Podcast. Is the moon moving away from Earth?
Okay, so for today's deep dive, we're tackling a question that honestly sounds a little strange at first. Is the moon actually moving away from Earth?
It does sound strange, but the answer is a very clear yes. It is. It's a phenomenon we call lunar recession.
And the numbers are just, well, they're incredibly precise. The source material says it's distancing itself at about 3.8 centimeters a year.
That's right.
Which, on its own sounds tiny. It's about the same speed your fingernails grow.
Right, but over millions or even billions of years, that adds up to a huge distance.
So how on earth do we measure something so small so far away?
Well, we're not estimating. We know that rate so precisely because of something called laser ranging.
Lasers? You mean we're literally shooting lasers at the moon?
We are. The Apollo astronauts back on missions like Apollo 11, they left these special mirrors, these reflectors, on the lunar surface.
Okay.
So scientists on Earth can fire a powerful laser, bounce it off those mirrors, and measure the round-trip time with just, extreme accuracy year after year.
That's incredible.
Yeah.
So we know how fast. Let's get to the why. What is the physical mechanism that's actually pushing the moon away?
It all comes down to gravity and a kind of cosmic tug of war. We all know the moon's gravity pulls on Earth's oceans, creating the tides. But the key here is that Earth spins much, much faster than the moon orbits us.
And the Earth isn't a perfect sphere either. It bulges a little at the equator.
Exactly. So because Earth is spinning so fast, that tidal bulge, the mass of ocean water, gets dragged slightly ahead of the moon's position in the sky.
Okay, so the bulge of water isn't directly underneath the moon. It's leading it.
It's leading it, yes.
Yeah.
And that bulge has its own gravitational pull.
So what does that do, that sort of off-center pull?
It acts like a tiny, constant accelerator. That mass of water is gravitationally pulling the moon forward, giving it a little energy boost.
Now this too.
And that boost is what propels the moon into a slightly higher and therefore more distant orbit over time.
Wow. And this has a counter effect on Earth, doesn't it?
It does. It's a perfect example of action and reaction. While we're speeding the moon up and pushing it away, the moon's gravity is pulling back on that bulge, and that pull acts like a brake, slowly decelerating Earth's rotation.
So our days are getting longer. I saw in the sources that billions of years ago, a day on Earth was only about 6 hours long.
That's the theory. It's just amazing to think about that kind of time scale.
It really is.
Yeah.
So let's jump forward. If this keeps happening over, billions of years, what are the big consequences?
The long-term implications are pretty profound. For starters, the tides, they'd become much, much smaller.
And that would completely change our coastlines, I imagine. Marine ecosystems, too.
It would devastate them. So many organisms rely on those tidal flows. But an even bigger issue is climate stability.
How so?
The moon's gravity is like a steadying hand for Earth. It stabilizes our axial tilt, the very thing that gives us predictable seasons.
Without the moon?
Our tilt could wobble erratically. You could have catastrophic shifts in climate over relatively short geological time, extreme ice ages, extreme heat.
And there's one more thing. For all of us who love looking up at the sky, eclipses.
Yes. That perfect, beautiful coincidence where the moon exactly covers the sun, that's temporary. In about 600 million years, the moon will appear too small in our sky to cause a total solar eclipse ever again.
So to pull this all together, our closest celestial neighbor is on a slow but constant retreat. And it's all because of this intricate dance of gravity and rotation.
It really shows how everything in the solar system is connected, always changing. And that brings us to a final thought for you, the listener, to consider. We know the moon's gravity also acts as a sort of cosmic shield, deflecting or capturing asteroids that might otherwise hit Earth.
A shield.
Yes. So as it slowly drifts away over these immense timescales, what might that mean for future life on this planet? The risk of a major impact, while still very low, will inevitably increase.